Hello, welcome to this week 4 discussion on traffic engineering. So it's 2 minutes to 7 p.m. So I'll wait for 5 more minutes to see if people join in and then I'll get started with today's session. Hi Rajesh, so I'll wait for a couple of more minutes and then we'll get started with today's session. I'll see if more people join in. All right. So since we have a couple of people join in this session, so I'll get started with today's session. Welcome to this week 4 TS session on traffic engineering. So today's topic of discussion will be capacity and level of service. So I'll get started with the discussion. I'll share my screen and probably I'll turn off my video. So let me share my screen. Okay, so I guess my screen is visible. So let's get started with today's content. So first let me write down the outline of today's discussion. So this is, as I have mentioned, is on capacity and level of service. So basic concepts of capacity and LOS. Then what was discussed in the class was analysis of basic freeway and multi-lane highway segments. Okay. Then within that you have some speed flow relationships, operational and analysis applications, those things discussed. So we'll see some of those. And finally, what we have is the analysis of two-lane highway segments, which was discussed, I think, very briefly, and the remaining discussion will be done in next week's sessions. Okay, so these are the basic topics that I'll be discussing today. So let's get started with the discussion on basic concepts of capacity and LOS. So now if I ask you this basic two questions, so what do you mean by the term capacity analysis, which have been discussed, I think, in the initial stages of the sessions, I think, that were shared in this website. And then you have this something called as level of service analysis. So let's try to see what these are and what are their differences and so on. So capacity analysis essentially means that a quantitative assessment of ability of a traffic facility to handle vehicles or people. So here we'll be looking at vehicles only, so it's in terms of vehicles in general. And then you have something called as level of service, so which tries to answer, or which tells you some performance, gives you performance level of a traffic system at various operating conditions. Now, how good this operation of a traffic facility is, it's what this LOS kind of tells you. So this is not a quantitative analysis, but it kinds of explains it through some qualitative analysis. Now, if I move into the discussion of, or just to understand the basic differences that I have talked about here. So this this has been, I think, discussed in the class as well. The traffic stream is composed of different modes, and now different modes kind of have different effects on the traffic stream. So this there can be cars, there can be heavy trucks, light trucks, some recreational vehicles, buses, and pedestrians, bicycles, and so on. And now this modes operate on variety of road segments, like some points that can be intersections, then that can be road segments, there can be some facilities, some like parking or those facilities as you can say, then there are corridors, and then you have areas and systems at larger geographic scales. So if I just summarize it, so one is the traffic or travel modes I can write, and then so this can be cars, trucks, and so on, motorcycles. Okay, let me add this in. And then you have uh, this roadway segment elements, which are your points, then you have segments, and you have facilities, corridors, and I think that should be good enough here. So these things are basic that elements roadway system. So I think that's I have written it wrongly. Now this traffic facilities again can be divided into uninterrupted facility. I think in this week's I think the discussion was only on uninterrupted facilities. So signaling and all didn't come here. I think that will come later in the course. So uninterrupted traffic facilities, and then you have interrupted traffic facilities, and there can be some other facilities like some bicycle lanes and so on, some bus transit systems, rail systems, and those things. Okay, let me write down other facilities. Now the discussion here in this lectures, in this week's lectures were on uninterrupted facilities, and these kind of consists of this freeways, which is basic freeways. Then you have multi-lane or two-lane, whatever, multi-lane highways as well. Sorry, this should be here. Or you can have two-lane highways. Okay, so now next the discussion I think was on capacity and mainly its definition that have been discussed. So let me do a new slide. So how do we define capacity? So capacity is defined as a maximum hourly rate, and the reason why this maximum hourly rate is chosen, and in specifically the peak 15 minutes of flow that are chosen, that have been discussed in the class, because you kind of have some steady or uniform kind of situation on the road where you kind of take care of all the heterogeneities that are out there in terms of travel modes and the other things that have been discussed. So if you want to define it, so it is typically, they can write the peak 15 minutes of flow during the analysis hour is considered, and then this peak 15-minute flow rate accommodates nearly all the variations in flow during the hour, because it kind of accommodates nearly all the variations in flow. So again, capacity is expressed in terms of persons or vehicles. So that have been already defined. Person capacity is kind of used in public transit systems and so on, but here I think the discussion is only on vehicles. And some more important pointers here is that this capacity is defined for a point or a uniform section, and this uniformity of the section being analyzed is an important criteria. And then this is also, capacity is again defined for prevailing conditions like roadway, traffic, control operations, or environment, and we'll see what are the base cases and how adjustments are needed according to the variations in these conditions. So as I mentioned, let's look at one of these conditions one by one. I think first was the roadway conditions that have been discussed. And for roadway conditions, this kind of includes the geometric and the other elements, like these can be number of lanes, lane widths, some design speed. So, and there are many others, but let's just write these for now. Then you have traffic control, or you can have traffic conditions first. So these can be your vehicle type, then directional distribution or lane distribution. Then you have driver population, like how familiar the drivers are in driving in those conditions and so on. Then you have control conditions, which includes traffic signal, then stop or yield signs, and the other signs like turn restrictions. Those are briefly discussed in the first week, I think, first week's content. Okay, so these are some of the basic stuffs. Then you have some technologies and operations. ITS can give you some additional info, and it can increase safety and performance, and real-time information can be gathered to improve vehicle navigation and so on. And the last one, which is the environmental condition, which is can be like your traffic facility can have some capacity, and that can be reduced depending on some environmental factors like some heavy precipitation, snowfall, then lighting conditions, slippery road surfaces, and so on. But we will be only focused on the base conditions. So let's look at only the base conditions for now. So let me open the slide. So in base conditions, what we have is that good weather, as I mentioned, the precipitations and those things should not be there. Good and dry pavement condition, slippery surface, and those things should not be present. Then you have users are familiar, like it's based on the driver population that I have talked about with the system element. And then you have no kind of impediments to traffic flow conditions, like no slow moving truck that are entering and those things. No slow moving trucks in the traffic stream. And then also you can have no narrow lanes, like a 3-lane road is kind of merging to a 2-lane road. That's not allowed here. And this, in most analysis in capacity, this finding out this roadway capacity, these prevailing conditions differ from the base conditions that have been defined here, and that means you need to have some sort of an adjustments. So prevailing conditions are different from base conditions in most cases, hence necessary adjustments are required to calculate capacity. Okay, so next I think the discussion was on level of service, like the basic concepts. So let's get into that. So for level of service, I have already mentioned this LOS is a quantitative. Okay, I think I mentioned it. Yeah, here I think in the first slide I mentioned it as performance level of a, yeah. So this performance level is kind of some qualitative measure, but actually if you are doing it, you are quantifying something, suppose some density, speed and flows and so on. So actually it's wrong to say it as a qualitative analysis, it's also quantifying something. So let me just maybe not write it here, and you can think of it as some quantitative analysis. So LOS is actually quantitative stratification of a performance measure representing quality of service, and where this quality of service term kind of, it's some qualitative term you can think of, which tells you how well a traffic facility or service operates from the traveler's perspective. And the traveler's perspective can be different from one traveler to another, so that's why you cannot quantify it as such. Now this LOS is typically given from A, level A, which is best, to level F, which is the worst. And this LOS for a given mode on a given transportation system element is defined by one or more kind of service measures. So we'll see what these measures are, but let's first see how this, you can define this quality of service. So this kind of is defined as I mentioned, how well this transportation facility is running. Now this can be assessed by some directly observing factors that are important to travelers. So it can be speed, delay, Then you have tracking some complaints from the users. You can survey travelers. Then what you can do, you can forecast traveler satisfaction, and then you can observe some services not directly kind of perceivable by the travelers, some average incident clearance time, and I think speed and arrival time at some work, those things you can think of. But I think if you just understand this first few points, that should be enough. And now there are several factors that kind of influence this quality of service. So factors influencing quality of service. So these are kind of pretty, as I mentioned, simple: travel time, speed, delay, reliability, comfort. Then you have convenience, safety. So some basic stuffs that travelers do care about. Cost, then accessibility to some facilities and so on. So these things, I think you should have some idea about how this quality of service kind of important, and based on that now you will go into the level of service where you have to do some quantitative approach you have to take. So LOS, it's kind of used to determine. So it ranges, as I have mentioned. Level A is best and level F is the worst, and this is according to Highway Capacity Manual. So I think HCM 2016 has been followed in this lectures. So let's quickly see what this LOS means. So it is a step function to begin with. I think this is one of the questions in the assignment as well. So the reason it is a step function, because you kind of segregate this level based on some control delay you can think of, or there can be some other measures that tells you some changes in LOS and so on. But now let's quickly see LOS A is, you need to remember that roadways are not designed, or are not typically designed to operate in this condition during peak periods. So actually what happens is that there is, but instead, some lower LOS that balances kind of individual's desire against the society's desire or financial resources, that are kind of balanced out by other LOS factors. And LOS F is, if you look at, it is either a breakdown condition where demand exceeds capacity, or there can be, most users would consider the system to be unsatisfactory for some specified service measure. So LOSF represents this breakdown condition. There's some noise in the background. Okay, so this is the big breakdown condition where demand exceeds capacity. So now let me see what uh, can be discussed. I think in this context there is some discussion on service measures. So I think it is like mentioned that each mode's travelers have different perspectives and could experience different conditions while traveling along a given roadway. So the service measures are also different for different modes and facilities. Like for motorized vehicles, or the pedestrians might have some different experiences, or bicycle users might have different experiences, as well as the transit of users as well. So it's like depend. So this in theory, this LOS and everything should be reported separately for each mode for a given system element. So LOS is actually reported separately for each mode for a given system element. So these are kind of basic concepts of this capacity and LOS. And I think then in the next module there were more discussions on this prevailing and base conditions, some influencing factors, and so on. So, or I think it was a discussion on flow characteristics as such, like some pre-breakdown flow rate, post-breakdown flow rates, and those things. So let me quickly discuss those and then get into the quantitative analysis of this level of service and so on. So the next discussion is on, as I mentioned, we'll be looking at uninterrupted flow facilities as well as basic freeways and multi-lane highways. So let's get into that discussion. Okay, so here we can distinguish between these two. So basic freeways are access controlled facilities. So these are grade separated cross streets and ramp movements to access the facilities and so on. So let me write then you have multi-lane highways, which is some uninterrupted flow that kind of exists. It's there with no control devices, no platoons are formed by upstream traffic signals. So these are kind of no traffic control devices, no platoon forming. Now we can do the analysis of capacities and level of service for each of this type of either this freeway or highway. Now I think in the course it was discussed is that the analysis of basic freeway and multi-lane highways highway segments are done with the same methodology because they have similar operating or operational characteristics. And this kind of common form of speed flow relationships and effects attributed to the number of lanes, lane width, those are kind of present for both. And then capacity and LOS, as discussed here for this freeway and multi-lane highway segments, will be from HCM 2016. So next is this flow characteristics, which kind of first tells you the speeds on multi-lane highways. So this flow characteristics, let me write down the key points. So one is that speeds on multi-lane highways tend to be lower so there are some presence of side frictions from uncontrolled driveways and intersections, as well as there are flows from opposite directions as well. And then you have there can be some isolated signalized intersections that can exist along multi-lane highways, but that's not the discussion right now. And the basic geometry of this multi-lane highways are kind of more constrained and is consistent with lower speed expectations. So this is the important point that you have to kind of remember. And if we look at the traffic flow, different types of traffic flow, you have one is the undersaturated flow. So when the traffic stream is unaffected by upstream or downstream bottlenecks, then you have got something called as the queue discharge flow, which is traffic flow that has just passed through a bottleneck or kind of is accelerating back to the driver's desired speed, and no other downstream bottleneck exits. So queue discharge flow will be relatively stable until the queue is fully discharged. So this is kind of, you can write relatively stable until the queue is fully discharged. And finally you have something called as the oversaturated flow, which is conditions within a queue. So this is that has backed up from a downstream bottleneck and reflects some consequences of a downstream problem and not prevailing conditions of the segment. So this is conditions within a queue that has backed up from a downstream bottleneck. Then there are some other terms that have been defined in the class. I think one is freeway breakdown. So let's quickly discuss those, and then I'll move on to the assignment questions. So this is on flow characteristics. One is this called freeway breakdown. So this kind of describes the transition from uncongested to congested conditions. So this kind of tells you about some formations of queue upstream of the bottleneck, and therefore the reduced prevailing speeds make the breakdown evident. Now there is, I think, one important term that have been defined here. So breakdown event on a freeway bottleneck is defined as the sudden drop in speed of at least 25% below the free flowing speed, which is I write it as FFS, for sustained period of at least 15 minutes, that results in queuing upstream of bottleneck. So this definition is according to the Highway Capacity Manual to 2016. Okay, so the next term that have been defined is called as recovery. So next is recovery. So you had a breakdown condition. Now this recovery is actually the inverse of breakdown, and there is again you have one term that have been defined as breakdown recovery on a freeway bottleneck. Is the return of the prevailing speed to within 10% of free flow speed for a, again, same definition, sustained period of at least 15 minutes without the presence of queuing upstream of bottleneck. Okay, then there is something called pre-breakdown flow rate and post-breakdown flow rates. So let me just quickly write these terms and then I'll probably talk about it briefly. So these are pre-breakdown flow rate is the flow rate that immediately kind of precedes the occurrence of a breakdown event, and again this is expressed in terms of passenger car units per hour per lane. And the post-breakdown flow rate is also can be called as the queue discharge flow rate or average discharge flow rate. So this is and this post breakdown flow rate is usually lower than the pre breakdown flow rate and resulting in some significant loss of freeway throughput during congestion, and average flow rate during this oversaturated period uh, or oversaturated conditions, that is during the time interval after the breakdown and before recovery. So that kind of indicates this Q when the Q discharge flow rate kind of is prevalent. So now what we can do, we can get into the calculations of capacity under some base conditions, and then we can have some adjustments according to it. So in the course, in the slides, let me check. Okay, so I think now let's briefly probably get into some of the assignment discussion, and then I'll come back and probably go ahead with the remaining discussions, because now I think the main concept and theory part are done. It's mainly about the problems. So let me open the assignment and check what other questions are. Okay, so let's, I think, solve some questions. I think some of them have been already discussed today, but some anyway, let's answer those now. So first is so write true or false type questions. The first is LOS is the quantitative stratification of a performance measure. Then you have service measures are the same for all modes and road facilities. Next is you have LOS is a step function. Okay, so let me see if there are anything that's relevant here. Okay, next is vehicle capacity is commonly used to evaluate public transit services, high occupancy vehicle lanes, and pedestrian facilities. Okay, next is roadways are always designed to provide LOSA during peak periods. Another one could be Q discharge flow rate is same as post breakdown flow rate. Basic freeway and two lane. Okay, let's not get into two lane right now. Let's talk about this one, breakdown event. Event on a freeway bottleneck is defined as sudden drop of drop in speed of at least 10% below the free flow speed for a sustained period of at least 15 minutes. Okay, so this is A. Okay, so what should be the answers to this problems? So you can type it in the chat if you want, because all of them have been discussed today in the class. Okay, let me check. So LOS is a quantitative stratification of a performance measure. Let's see if anyone. Okay, let me actually flash this so that I can have some answers, and then I'll be talking about all this. Okay, so someone said A is true, which is correct. This is true. What about the other? B's service measures are the same for all modes and route facilities. Okay, so any answers to this? Okay, C is false, B is false, both. Okay, someone said C is false, some other person is saying C, is it true? Okay, Yeah, so B is false, that's correct, because it's not the same for all modes and load facilities. LOS is a step function, that is true. Uh, that have been also mentioned in the slides as well, and I have also mentioned it today. What about D, E, F, G? Any answers to that? Yeah, so someone asks both A and C is true. Yeah, that's correct. Both are true. C is true. Yeah, C is not false. C is true actually. What about D, E, F, G? Okay, so let me see. D is true. Yeah, D is it true? Okay. Vehicle capacity is commonly used to evaluate public transit services, high occupancy vehicle lanes, and pedestrian facilities. So, in the definition of capacities, if you remember correctly, it was mentioned in the beginning that capacity analysis is a quantitative assessment of ability of a traffic facility to handle vehicles or people. Now there are two different kind of segments that you can think of. One is a vehicle capacity that have been talked about. Other is that something called as people. So I think in one of the slides, I think, yeah, person capacity is the word that they have used. Now if you look at this high occupancy vehicle lanes and then pedestrian facilities, public transit systems, these are kind of demands that are related with person and not the vehicles. And since it's evident from this last one, which is called as the pedestrian facility, so this is actually not true, because here it should be person capacity which is commonly used to kind of evaluate all these things. So it doesn't matter what the vehicle capacity is in such a case. So this should be false. Okay, D is not true. Many people have written D is true, but actually it should be false, because I think it's in the initial slides itself it has been mentioned that it's person capacity, not the vehicle one. E is true. F is okay, not written. G is true. Someone also wrote E is reject, means false. Okay, so we have some confusions regarding E. This is mentioned that roadways are always designed to provide LOSA during peak periods. This is not true. This is again false. And again, this is uh, in the slides itself, it was mentioned that uh, there is some other levels of service, something which is lower, probably B or C. Those are kind of designed to provide during peak periods. So it's not like you get the best facility during peak periods. So it's the design doesn't happen like that, that you can travel as per say free flow speed during peak periods. So this is false. F was this is Q discharge flow rate is same as the post breakdown flow rate. F is no one has written. Yeah, this should be true. Again, this is just another name of post breakdown flow rate, and again it was mentioned in the previous slides as well. Finally, this breakdown event on the freeway bottleneck is defined as sudden drop in speed of at least 10% below the free flow speed for a sustained period of at least 15 minutes. This is, someone wrote it as true, but why is it true? Let me check. This is the breakdown. So this not to be confused with uh, recovery. So breakdown recovery is another term which tells you the return of the prevailing conditions to 10%. But here we are talking about breakdown. So this is sudden drop in speed of at least 25% below the free flow speed. This is not 10%. So you have to check carefully which one is 10%, which is something related to recovery, which one is 25%, which is the breakdown. So this should be again false. So yeah, many people did some mistakes, but yeah, I think this should be clear to you. You should pay some attentions with on this numbers and also check the slides. I think these questions are directly from the slides itself, so you'll get the answers there itself. So now let me move to another discussion on assignment problems. Yeah, so I think if I give it to you like this, maybe this is good that you are answering it. Then I'll know exactly whether you are making mistakes or not. So it's a matching problem. Okay, so I should do. Oh, sorry. Okay, so let me write down the problem. So this is column, say, X. This is column Y. So you have to match within this, or I can just write numbers here. So suppose 1 is LOS A, then I have 2 which is LOS B, 3 is, or let me write it as C, this is as LOS E, and 4 as LOS F. So in column Y I have, so these are defined. So suppose I defined A as, or A, this number is not to be confused with level of service, it's just for giving you the answers or matching purposes. So this is, say, free flow operations. Then B is, suppose, breakdown conditions. Then your C is operation at capacity, and D is local deterioration in service quality is significant. So what would be the answer? So I'll ask you to match this column X and Y. So whether 1 should be matched to C or D or A, B, whatever, and 2 should be matched to again A, B, C, D. Those things you have to write it down. So you can write it in the chat. So what would be the answer to this? Okay, any answers to this one? Okay, yellow is okay. 1A, 2D, 3C, 4B. Okay, so I think that's correct. 1 is A, that's fine. 2 is D, 3 is C, and 4 is B. So F is when the breakdown occurs. Yeah, A is free flow, C is local deterioration, E is operational. Correct, yeah, that's the correct answer. And I think these are kind of explained in the course, like lecture slides itself. Let's look at maybe one more problem in this nature and then move on to one numerical after that. So in its I think I need let me sorry. So I wanted to add let me delete it. Should be 4 columns. Okay, now it's fine. So this is column X, this is column Y. So the first one is signalized intersections. Then you have freeways. And then you have 2-lane highways. And here you have density. Then you have average travel speed, and you have delay. So these terms are related to which kind of elements you have to mention. So what would be the answer to this matching problem? Okay, freeway is, yeah, correct. Plus one. Yeah, these are correct, but it's not related to this question. So maybe if you can write answers. Okay, 1A, 2B, 3A. Oh, no, like how can two answers be A? So that's not true. Okay, someone mentioned freeway is density. So that's correct. So 2 becomes A. Then you have signalized intersection, which is 1. So what would be the answer to that? A is 1. No, A is 2 actually. That's not true. Yeah. So there are always delays that are kind of measured because at signalized intersections you have control devices. So this should be C, and 2A, and then 3 would be automatically this 2-lane highways. The discussion kind of relates to the average travel speed. Yeah, sure. Oh, here it's not about high or low. I think it's about the performance measure. So when you try to find out the LOS, so we check for densities, right? Because we don't check for speeds, because the speed curve remains kind of constant before that breakdown period. So in order to check for flows, we kind of relate it to densities. So that's why its freeways are kind of directly relate. It can be some relations that you can think of here. So that's why it's density. It's not about high. Yeah, 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 correct, correct, correct. It's the measurements. That's the correct word. Signalized intersections we measure delay, and then 2-lane highways we kind of measure average travel speed. So that's the correct answer here. Let's check what's there in the assignment. Okay, let me open it. Okay, maybe one more uh, true false type problem, then I'll move to one numerical. Okay, so the first one is speeds and capacities of multi-lane highways are lower than those on basic freeway segments with similar cross sections. That's one thing. Let me extend this. Next is speed is taken as the service measure. We just discussed this now for defining LOS. Then you have when demand exceeds capacity, it represents the conditions of LOSE. Again, it has been discussed in another question. And in speed flow curve of basic freeway segments under base conditions, breakpoint is constant for different free flow speeds. Okay, so what would be the answers to these problems? Okay, any answers to this? Okay, these are discussed, so I'll just quickly tell this is true. Speed is taken as the service measure for defining an LOS. This is false because just now we discussed that density is the one that is taken. And when demand exceeds capacity, it represents LOS F, not this one. So what about the last one? Can anyone answer this? In speed flow curve of basic freeway segments under base conditions, breakpoint is constant for different free flow speeds. Is it true or false? Okay, true, false, false, false. Yeah, correct. This is also false. The reason being is that you can check for that speed versus flow rate curve, and depending on different LOS levels, you kind of fall in different density categories. And if you have different speeds, and then your flow rate won't be the same where you hit the breakpoint. Your flow rates are kind of different when you reach this breakpoint. So this is not true, that's false. So I think that's all about this conceptual type questions. Next is, I think, numericals are there, couple of numericals. So let me see if we can solve such problems. Okay. So one is, let me give you the data. Yeah, go ahead. Yeah. Uh, this one, which of the following statements are true? Yeah, yes, you can have, yes. Hmm. Oh. Oh. Hmm. Huh. Okay. Hmm. Oh, okay. Okay. So I think what I would suggest, you post this issue in the discussion forum. So there will be ask a question thread here. So once you do that, I think the instructor should take a look at it and probably resolve this issue, because I don't know how it goes. It's an issue from the NPTEL team's site, I think. Yeah. For me, suppose I select A and B, it's fine, right? I'm able to do it. Uh, it's not locked. Okay, this. Okay, so in general, I think, I'm not sure. Maybe here you have only one statement which is true. Here it's written is true. It's not written which of the following statements are true. So, but anyway, the assignment answers are released, right? The previous weeks. If there were such issues where you have seen that there are multiple answers, but you got partial marking for that, you can raise that issue in discussion forum, and they will resolve it, I think. Yeah. Okay. Any more doubts? Otherwise, I'll move to the numerical. Okay, so let me give you the data for this. So this is a basic freeway segment that we are talking about. And then we have adjustment factor for lane width. So this adjustment factors and all have been discussed in the class. For lane width as given as 1.9 miles per hour. Then you have adjustment factor for right side, lateral clearance for 3 feet, clearance on freeway with 2 lanes in one direction. This is as 1.8, and finally you have this total ramp density equals 6 amp per mile. And then you have default base value of speed is 75.4 miles per hour. So the thing that is asked here is that what is the free flow speed in miles per hour when it is operating under ideal conditions. So this is what you are asked. Now let's see how to answer this. So I'll just reduce the font size a bit. So now in the lectures I think you had one formula which was given as this free flow speed equals this base whatever this free flow speed minus f of some LW minus f of RLC minus let me check the expression once. Yeah, 3.22 times TRT, and then you have an exponent which is 0.84. So here BFFS is the base FFS, which is the free flow speed for basic highway segment, which is given here. FLW, and this tells you the FFS adjustment factor for lane width. Okay, so I think I got it wrong. Okay, then you have FRLC, this is equals the FFS adjustment factor for right side lateral clearance like you have to also considering some number of lanes in each direction, so we'll see how to calculate this. And finally you have this TRT, which is total ramp density. So if you look at this total ramp density can be used directly here. This BFFS is directly can be used from here. FLW is also can be directly used from here, but there are slight adjustments you have to make to this FRLC because it considers this clearance as well as how many lanes are there in one direction. So for that you have an expression. Let me check. FRLC is Okay, I think it is the standard conditions that have been written here, but just to double check, I'll just see. So this is the right lane. Okay, so yeah, this is the correct one. So actually everything is given here. So this is the standard one with 3 feet clearance with two lanes in one direction. So this problem is just about simple application of this numbers that have been given. So this is 75.4 minus FLW is 1.9. Then you have this as 1.8. Then you have minus 3.22. These are all in miles per hour, so that's fine. TRT is in ramps per mile, so that is also fine. So this is what you will have. So let me compute this expression. Okay, so I'm getting 57.285. So this would be the answer. So this was a very simple problem. Did anyone write? Now there is another problem with the same data. So let me just copy this. And write a new problem, which is calculate the base capacity of the freeway segment. So this is in passengers car per hour per lane. Okay, so for this again you have a formula that was given in the slides. So let me quickly check what the expression was. So for free flow speeds we have made the adjustments. For capacity there was another expression. So this is capacity. This is for basic freeway that we are looking at. So this is equals 2200 plus 10 times FFS adjusted minus 50. Now we already know what FFS adjusted is. So this is plus 10 yeah, here it is a standard value. It won't change here. That's correct. Yeah, in case of any confusion, you can also check highway capacity manual uh, 2016. So there you will find this. So this is standard value for specifically basic freeway, but expressions will change if we are using multi-lane freeways. And also I think mm, this expression is also valid when you have your base capacity. I think that shouldn't exceed, I think, 2400. So let me just work it out and see what's the final value here. It's so this one is not 75.4, but the adjusted one that you got is 57.285. This is minus 50. So let me get the value. So I think it's 2272.85. This is okay. So I think this expression is valid if this final value that you get, it doesn't exceed 2400, as well as I think this default base value of speed is around the 75. So if it's, I think, more than the 75.4, I think this won't work. But in general, I think you'll be asked questions related to this. Uh, but let me check if the solution that I've done is correct. Yeah, it's calculation seems fine. Yeah, this is the correct answer. So now if I ask you, or if I give you a different data, instead of say basic freeway segment, I give you a two-lane highway, then this adjustment factors and everything, so whatever is asked here, that won't be like valid. You have to use a different formula for that. So maybe let's look one more such numerical before maybe I'll conclude today's discussion. So let's try this out. Okay, so maybe just okay, maybe I'll just give additional data and ask to find you the LOS. So your additional data could be, say, lane width is not required. Um, okay, maybe not go into the lowest discussion because it will take some time. But let's look at this another example on multi-lane highway. Anyway, let me just check if there is anything that I missed. Okay, so someone was talking about this class 1 two-lane highways and class 3 two-lane highways. I think you can answer these. That's not a problem. Yeah, here also I think there will be, should be one correct answer, but I have to check. Okay, so this I already discussed. Okay, so these are discussed. Okay, I think you can answer these as well, not a problem. Okay, so this is related to two-lane highways. Okay, so let's maybe just solve one more numerical. So let me give you the data. So what you have is, so this is on multi-lane highway. So you have a 5-lane highway. So by 5-lane, it is meant that two travel lanes in each direction plus a two-way kind of left turn lane. And you have the characteristics as, then you have base, okay, is it different? Okay, yeah. Okay, so next is lateral clearance on both sides of roadway, 10 feet. Okay, instead of 12 feet, okay, let me give, keep it as 11 feet. Then you have so you have additional information on median here. Two-way left turn lane, and in addition to this, you have an information on access point density. Is it? Yeah. So you have eastbound equals 10, and you have westbound equals 0. So now I'll ask you, what is the adjusted free flow speed? So in order to solve this problem, so we have sufficient data. Now how to use this is the challenge. So first we have to see what the formula is to calculate this free flow speed in multi-lane highways, and the formula is again similar but with slight differences. So you have that base free flow speed, then you have based on lane width you have an adjusted factor, then you have total lateral clearance, based on that you have an adjustment factor. Now you have an adjustment factor based on median, and finally you will have another with respect to access points. Now let's check what are the values are. So this base FFS, which is BFFS, this is considered as the posted speed limit that have been given here plus 7. So that's the standard norm given in HCM. So this you can calculate. So this is 52 miles per hour. Next is you need to find out this FLW and FTLC. So as per highway capacity manual, for lane width of 11 feet, your reduction of this free flow speed or FLW is, so your FLW here becomes 1.9 miles per hour. So this is because lane width is 11 feet. Next you have to calculate this TLC. Again you can check HCM and there would be one table which tells you for 4-lane or 6-lane highways what is this FTLC values. So here you have lateral clearance is 10 feet at each roadside, and maximum can be 6, maximum value of 6 feet can be used. Okay, so you have the data for 4-lane and 6-lane. So we have to find out for the 5 lanes. Okay, so for 5 lanes also some interpolation gives you so this has 0.4 miles per hour. So this is from the table, I think it's exhibit 1222 something, there you will find these values. And then you have this adjustment for median type, I think it's exhibit 1223. So here you have sorry, is there any message? Sorry. Okay, so the question is according to HCM 2016, okay, speed adjustment factor for base condition on a basic freeway segment is 1. I think it is false. Okay, speed adjustment factor for base condition, let me check quickly. Okay, so yeah, so the speed adjustment factor okay, I have to check exactly, I don't know, because the adjustment factors are generally with respect to this lane widths and this right side lateral clearance, and also I think total ramp density for basic freeway segment. So I'm not sure. So those are the adjustments that are taken care of. So I'm not sure additionally if there is some speed adjustment factor that was discussed. Um, for multi-lane highways, we do have additional ones with access point and median type. Okay, maybe I'll check and let you know. Or you can post this in discussion forum so that I'll look it up and maybe answer it to you. Okay, so let me go back and finish this. So for median, I think yeah, what's the adjustment factor? Let me check. Okay, so okay, for medium type that we are considering, it's two-way left turn lane. So for that it is 0. If it is undivided, it is 1.6, and if it's divided, it is 0 again. So here it's 0, so it won't matter. And finally we have this access point densities, and eastbound is given as 10. So for eastbound we can write FA of eastbound, so that becomes 2.5 miles per hour because it is given as 10. And for the westbound, okay, so this would be 0 because it's given as 0. Yeah, for 0 it is 0. So finally you will have free flow speed, two different free flow speeds, adjusted free flow speeds. One is for eastbound. Now this is calculated as 52, which is this one. Then you have FLW, which is 0.4. Sorry, it is 1.9. Then you have 0.4 for the next term. FM is 0, and for eastbound it is 2.5. So this will be your answer, and the other portion will be for westbound it is 52 minus 1.9 minus 0.4 minus 0 minus 0. So let's see, let me calculate, and this would be your answer for this question. Okay, so this is 47.2, and finally this one would be okay, 49.7. So you might get questions like this one as well. And then for this is just a sub problem, you might also get some questions asked about adjusted capacities, and then maybe some information about demand will be given, and then based on the estimation of densities you can directly relate it to which LOS it belonged to. So I think I have covered most things, but I think one thing I didn't cover today is a discussion on two-lane highway, but anyway, only the concepts were kind of discussed in this week's content, and the numericals and more detailed analysis are presented in next week's discussion. So I'll be discussing that next week. And I think the assignment problems are mostly covered in today's discussions, and if you go through this slides also, you will see the relevant points kind of highlighted. So yeah, I think with that I will stop for today. If you have any doubts, you can ask me now, or you can later post it in the discussion forum. The TKS will answer those. So yeah, any doubts you can ask. Okay, if no doubts, you can feel free to leave the call. We can meet next week again. Okay. Is there any doubt, Rajesh? You can ask or you can post it later as well. This one, yeah, I'll check. Okay, you have one doubt. Speed summit. Yeah, it is true because in multi-lane highways, you have to check for also the traffic that are coming from the opposite direction, and based on which overtaking, the safe gap measurements and all those things comes into picture. So the speeds are actually not that high compared to a basic freeway which is grade separated. So this is true, this statement. Okay. Okay, so I'll close today's session. See you all next week. Thank you.